and I have a returning guest. And hey, Doc, I think you're one of my top returning guests on this show. I think this is your fourth or fifth time back, and
Wow.
I was looking at all the stats, and I'm like, wow, Dr. Seneff, like I've had her on quite a bit, but yet it's been so spread out that
hmm
it's it
It's
it
gone
was
back years.
yeah,
Yeah.
it goes back a couple years. But Dr. Stephanie Seneff, welcome back to the show. It's great to see you.
Great to be here. Thank you.
You're very welcome. So we have a lot of new viewers since you were on last time, and I would love for you to give a little background on who you are and where you come from and your credentials because you're a genius.
I'm at MIT. I've been at MIT pretty much all of my adult life, starting with an undergraduate degree there and have a PhD from MIT in computer science and electrical engineering, undergraduate degree in biology. And all my research career was at MIT, and I'm currently a senior research scientist, which is the highest rank on the research staff. So I love MIT. My four sons all went there too. So we're an MIT family. And
Hey, go ahead.
go ahead.
Yeah, and so you have been studying and this is so funny because we were talking before the show, and I was like, wow, it's really good because you have been on the forefront of some absolutely amazing movements from glyphosate to vaccines to now we'll call it the C virus or whatever you want to call it. But the great thing is your voice has been allowed out there to actually discuss these things and be, I don't want to say an alternative voice because natural health really should be the priority. But you you haven't even been silenced, which is really awesome because you just give us data, facts, statistics in this world of, I will admit, a lot of conspiracy and a lot of generalization of things. You just bring actual numbers and real facts up to the surface. And so
Thank you.
you've been talking about glyphosate for a long period of time, but then when we emailed back and forth, you said you had some information regarding glyphosate, the virus, many different things. So I'm going to let you jump right into it and give us kind of what you've been studying and seeing, and I will bounce questions off to you after that. How does that sound?
That sounds great.
So, what
And
have you been finding?
well, as soon as COVID hit, I started to get interested in the possibility of glyphosate playing a role, and particularly as I learned that all these risk factors, heart disease, diabetes, high blood pressure, obesity, risk factors for bad outcome. I happen to know that all of those are conditions that are going up dramatically in our country, exactly in step with the rise in glyphosate usage. And I believe glyphosate is causal. I mean, people say correlation doesn't mean causation, but I disagree with respect to glyphosate. I think it's a direct causal effect. And when you look around the world, when countries adopt a Western diet, start getting a lot of glyphosate in their food, they start getting fat, they start getting diabetes. It's happening around the world. So America, U.S. is really the biggest consumer of glyphosate. We have more glyphosate per person in our food supply probably than any other country. Brazil might be a close second, but United States and Brazil are also number one and number two on COVID-19 deaths. We have huge problems containing the infection. Other countries, not so much, and it's quite remarkable when you look around the world at the different countries and how well they're able to contain the virus. And I like to look at Taiwan because Taiwan has had something like 450 total infections with 7 deaths. And that's been very steady for a long time. Like they basically don't have the virus right next door to China. And, they're careful with masks and whatnot. And people say, well, that's why they're just so good at social distancing and contact tracing and all of that. And then I'll give them credit for that. That could be helping. But the difference between Taiwan and the United States is stunning. For every one person who dies in Taiwan, 2,000 people die in the United States, even normalized by population. So,
Wow.
it's quite interesting that some countries seem to get hit hard, some don't. And when you look at the ones that do, you pretty much see a very striking pattern, which is all of the Americas, North America, Central America, South America, and all of Western Europe, pretty much. Those are the hardest hit. They're the ones that are having a really hard time controlling the infection rate. And coincidentally, they're the ones that use a lot of glyphosate and that have are leaders in the biofuel industry. And so biofuel is the thing that really caught my eye. Early on, when I first started seeing Wuhan, I was aware that Wuhan, I know from my husband actually is Chinese, and he had visited that area, and the host had shown him massive fields of canola crops that were being used as a source for biofuel. And I know there was a glyphosate manufacturing plant on the Yangtze River that goes to Wuhan. So I'm having a hard time getting confirmed information about Wuhan, but I suspect, even looking there, that it's air pollution, glyphosate in the air, breathing the glyphosate, harming the lungs, harming the immune system in the lungs, and preventing the person from responding appropriately to the virus, which would be completely not a problem. It probably wouldn't even be a cold. If you get the virus, your immune cells remove it, and you're done. That's the way it should work. But when you've been chronically exposed to glyphosate, it doesn't work that way. Your immune system gets wrecked by the glyphosate and other chemicals in our environment as well. I don't want to put all the blame on glyphosate because we have a lot of chemicals. The United States is quite comfortable with using chemicals to control weeds, chemicals to control pests, insects, fungi. We just like to use chemicals as a solution to our problems with organisms that give us trouble. So we're paying a huge price because everybody in this country is being chronically poisoned, and we're poisoned from the food, and some people are poisoned from the water supply. But then the air becomes a very interesting question, and I don't have proof. I will say that right up front. But there's a really big smoking gun here because when I look even within the United States at the places that have huge response, I look at when the virus first arrives, does it fill up the ICUs? So it comes into a city like New York City, and the ICUs are overwhelmed with all these sick people coming in that can't breathe. That shows you that you have a large population of people who can't resist the virus. And then the question is why. And so New York City actually was something that really caught my eye. It was Lombardy region in Italy and New York City, which if you remember early on, those were places that got hit really hard. It really kind of got us to wake up and realize this thing is serious. And so New York City is actually very advanced. New York State is very advanced in the biofuel industry, and New York City in particular they've been really pushing the use of biofuels in for different energy sources. For example, biodiesel, ethanol in the cars, bio home heating oil. So New York City is the only city I have found that requires 5% bio in the home heating oil if you heat your home with oil. And then there's also biogas, which may be the most interesting one. I don't know which of these is more troublesome than the others, or whether any of them are. I don't actually know. So I have to say it's a theory. But it really works well, I feel, when I look at how things are unfolding in the world. There was a paper that came out from Harvard that looked at county-wise. They looked at the nanoparticles in the air. So this is looking at air pollution and whether that's a factor in the C virus. And they found a striking correlation that there's a higher death rate per population in the counties where were higher nanoparticle levels in the air pollution. And so, and then Europe had 3 papers that talked about link between air pollution and bad outcomes. But then when you look at air pollution around the world, which I did, you can find nanoparticle levels for different countries and plot that against C virus death rate per population. And the thing, it doesn't work at all. It almost goes the opposite from the trend you would expect, that high air pollution is protective against C virus, which doesn't make any sense at all.
Really?
It's not really protective, but what it means is that it's not just air pollution. It's air pollution plus glyphosate. That's what I think. If you have air pollution without glyphosate, it's harmless. And it turns out those countries that have air pollution without glyphosate also don't have glyphosate in general, and therefore they're protected from C virus because they're not being exposed to glyphosate. So high air pollution without glyphosate is a marker of glyphosate, of reduced glyphosate exposure, which is what's the key factor. It's not the air pollution, it's the glyphosate in the air pollution. I think that's really, really troublesome.
We're technically like, I remember seeing this map, and there's a website that I'd have to go back and look up where it is, but it basically shows, I think, not just glyphosate, but also, I mean, plethora of other herbicides, fungicides, pesticides, and it shows from like 1970 up to like 2018. And it had a map where it was like a heat map showing where everything was. And from where it started with glyphosate to where it is now, and the entire map is just like starting to be fully covered. And we like to think, I guess, that, oh well, glyphosate, it's sprayed on the food, it's okay, it's not going to be harmful because that's what they tell us, and that once it's on the food, it's okay, it's just going to stay there and maybe into the soil. But we're kind of living in this cloud of I mean, this stuff is airborne, correct? I mean, it's got to be everywhere particleized. I mean, am I correct? Can you expand on that?
Well, that's a big question. I mean, glyphosate can get aerosolized out of, for example, particularly with the gas. That's why I'm thinking of biogas, and I'm particularly intrigued by um, the outbreaks that we've seen on cruise ships. Early on, we saw some really big outbreaks on cruise ships, and I looked into that, and I found out that the cruise ship industry has recently introduced the concept of they have a lot of food waste on the cruise ship, and so what they've done is they've installed these anaerobic digesters on the ship, on board the ship, where they put this food waste into this digester, and they have these microbes that go and break it down, turn it into biogas. And then exactly what they do with that biogas, I don't know, but they might just release it on the ship. Or it may leak. I mean, it may be that that biogas is contaminated with glyphosate and the people on the ship are breathing it. This is, again, just a theory. I mean, I have to say all of these things, I've not proven any of it. I'd love to get someone who could do the work to try to look into it and see if there's something to it. Glycerol was something that I picked up on early on. I was actually aware of a disease, of a lung disease that was showing up in people who smoke e-cigarettes, the vaping
Yeah.
industry. And the e-cigarettes, their base is glycerol. And glycerol is a byproduct of the biofuel industry. It's the major byproduct of the biofuel industry. When they break down the fats, they end up with this glycerol. And so there's a glut on the market, and it's probably quite cheap at this point for that reason, because of the biofuel. And biofuel industry is really ramping up right now, too. I didn't realize that until I looked, but they're really accelerating the introduction of biofuels into the fuels. We have biodiesel, bioethanol. In the U.S., we have 10% ethanol. Europe has a lot of biodiesel. They run a lot of diesel cars, and they import a lot of that biodiesel from Argentina, which is GMO Roundup Ready soy. And then we also have New York City has this massive, I think it's a 50-acre site where they process the New York sewer. All the sewage that comes out of New York goes into this processing plant, and they add other stuff in there as well. And they capture the gas and they use that and sell it back to the community. So if you have leaky pipes underneath an old city such as Chelsea, Massachusetts, and also in New York, I suspect the same thing is true for Brooklyn and Queens, which was really the epicenter of the epidemic when it first hit in the United States. And that processing plant is there's this little creek that separates Queens from Brooklyn, and that plant is situated on that creek, and it processes huge amounts of sewage, and it captures fuel that it can use to give back to the community in the form of gas through these massive anaerobic digesters. So these beautiful big eggs that they have, they call them eggs, anaerobic digesters. So if you think of leaky pipes under the city, I know Chelsea, Massachusetts is by far the worst in terms of the COVID death rate, COVID infection, C virus infection. And Chelsea, has had a problem with gas leaks in the gas lines that are underneath the city, and Chelsea has been a leader in the biofuel industry going way back. I found an article from, I don't remember, 2003 or something, a really old article saying at that time they had like 75% of the biofuel development was in Chelsea. So it started there, and they have these big oil tanks where they store all of the gas, all of the aviation fuel for the airport, which is right next door, Logan Airport. Chelsea's just full of these big giant tanks. They store home heat. They store food oil from the restaurants. They get the used oil from the restaurants, and they have this big tank that stores that. And they had a fire a few years back. They had an incident where this food oil caught on fire. So I know they're doing a lot with biofuels, and they're storing a lot of tanks of various kinds of fuels. So you can imagine that something's leaking out from somewhere. It could even be at the gas station when you're filling up with the diesel fuel for a vehicle. New York City has something like 11,000 buses that run partly on biodiesel. So, you just picture an old bus with a poorly tuned engine. I think there's ways in which you could imagine it's getting out into the air. I wanted to get back to the smoking, because those e-cigarettes, they had this strange lung disease, and I had been looking into it before C virus even hit. And that lung disease looks exactly like the symptoms that you see for people who get sick with this virus.
Really?
It's a dry cough and shortness of breath, a slight fever, and sort of lung lung disease with a dry cough. And they had done.
You're the first person I've ever heard say that, which now really fascinates me because what are you on to now? What does this mean?
I know. So, especially, they especially mentioned this lack of a runny nose, which is characteristic apparently of this disease as well, and also characteristic of this disease with e-cigarettes. And so they've done studies on the e-cigarettes, and they've confirmed that it's not just the nicotine. Like even without the nicotine, you still get sick. And they've done experiments with mice, and a really, really interesting study that I've read carefully with mice where they exposed them to the vapors from e-cigarettes, just the vapors from the glycerol without the nicotine. And they did it both both with and without the nicotine, but the nicotine didn't make a lot of difference. It still had a bad reaction even without the nicotine. And it was basically glycerol, and as I said, byproduct of the biofuel industry. And they looked at and they predicted that they would have a very bad response to the flu virus. So they actually exposed them for, I think it was 4 months, to these fumes, and then they intentionally exposed them to the flu virus, and they compared them to the controls. And lo and behold, they had this very intense immune reaction to the flu virus, which is exactly what we see with a bad outcome with the C virus. You see this incredibly strong immune response that gets inflammation, and everything goes on fire, and you damage the lung tissues. And that's exactly what they saw with these mice. And in particular, they saw two specific things that I find really interesting with respect to glyphosate, because they found fatty deposits were accumulating within the immune cells that had come into the lungs to fight the disease. They were accumulating fat. And glyphosate has been shown specifically for the liver to cause the immune cells within the liver to accumulate fat, just the exact same thing. Mice, rats that were exposed to glyphosate at levels that were below the regulatory limits in the United States developed fatty liver disease. And we have an epidemic in fatty liver disease today that matches with the exposure to glyphosate. Probably also a risk factor for a bad outcome, fatty liver disease.
Yeah. Is it now? I remember you telling me, and this is part of your work that people have noticed, is with glyphosate, it takes the glycine molecule out, I believe. Now, is glycine and glycerol tied together at all?
It sounds like it should be, doesn't it?
It should be, and I don't think it is. But I wanted to make sure I wasn't like,
Yeah, they're different. I mean, they're kind of cousins. They both come out of a pathway. There's a common. They're a bit, but they're different. They're very different. But you're right, glycine. So what I believe is happening with glyphosate, and that's my big theory, which is that it's getting into proteins by mistake in place of glycine, which is one of the coding amino acids. There's about 20 amino acids that are so powerful in biology. That's the DNA code. We hear about the DNA code, the 4-letter code, and it's 3 letters in a sequence that code for a specific amino acid. And it's a redundant code because there's 64 possible combinations of 3, but there's 20 amino acids. So the codes that code for glycine, when the protein is being assembled, what I think is happening under certain circumstances is that the machinery is making a mistake, because glyphosate is a complete glycine molecule. It just has extra material stuck onto its nitrogen atom. So it can fit into the spot where glycine would normally go. It has no side chains, just like glycine. That's the unique property of glycine. So that's how you distinguish glycine from the other amino acids, is because it has no side chains. And the same is true for glyphosate. So it should fit beautifully into the socket where glycine is supposed to fit. And therefore, the machinery will mistake it for glycine and put it into the protein. And certain proteins where that happens, if that happens, it's devastating for that protein. So I've been accumulating a list of proteins that I suspect are being damaged by glyphosate, and then I'm linking those to the diseases that I'm seeing are going up in response to glyphosate exposure. I'm seeing all these diseases that are rising dramatically. There's a long, long list. And for each disease, I'm sort of looking at the underlying mechanism of that disease, and then I can link it to specific proteins that I can predict would be disrupted because of what I know about those proteins. So it's quite an interesting puzzle, and the pieces are really flying in place to explain all of these diseases that are going up dramatically. So it's a slow kill because it gradually accumulates in your tissues. It gets stuck in certain proteins and then those proteins can become very hard to break down. So I think, for example, Alzheimer's is a disease that's going up exactly in step with glyphosate, which is a really disturbing disease when old people can no longer have cognitive dysfunction to the point where they're a severe burden on society. And it's related to amyloid beta plaque, which is a misfolded protein. And the amyloid beta has this particular sequence in it that's a GXXX sequence that's particularly singled out as the place where it's getting messed up. And that's got these glycines that are super critical to form an alpha helix. And if you replace those glycines with something else, the helix doesn't form, it becomes soluble. And then it accumulates into these it conglomerates into these soluble fibers that the body can't remove. And that's how you can get Alzheimer's disease. So that's just one example of a protein where you could explain it by this effect that glyphosate would have on that protein.
Jeez, I feel like whenever I talk to you, I learn so much. And then it's interesting because if you're in the natural health world and we're in clinically all day, you tend to get pulled in different directions, whether it be water or it be medications or it be other like the toxins of the world. But then I always talk to you and I'm like, man, this damn glyphosate. We're back to glyphosate. And I feel like glyphosate is it's becoming everywhere in the body. I mean, it's because if it is airborne, then we're definitely taking it into the respiratory system. And then we do have this whole thing with the pandemic. And I'm obviously, we're not getting all the true stories through the media. Obviously, it's been completely messed up. But it would make sense that the lungs are becoming a problem and you have glyphosate. I mean, people, especially in the cities, and if you have stuff in the fuel because of the corn and the crops, we're back to glyphosate again, Doc.
Yes, I know. And the thing is, I didn't finish the story about the lungs with the mice that were being exposed to the fumes, because there was another thing they noticed about the lungs, which was that they have these surfactant proteins that they produce. We have the same. And these surfactant proteins were deficient in the lungs of the mice that were exposed to these to the glycerol. And the surfactant protein, I had already singled out that class of proteins as being vulnerable to glyphosate because they have something called a collagen-like stalk, these surfactant proteins. And that stalk has these long sequences that match a characteristic feature of collagen. Collagen is the most common protein in the body. 25% of our protein is collagen. And collagen is the glue that holds your joints and your bones and your skin together. And people are having a lot of issues with collagen, problems that's causing bone pain and joint pain and weakness and poor joint function, which I suspect is due to glyphosate getting into the collagen. But these collagen-like sequences in the stalk, they have this long pattern of GXY. Every third amino acid is a glycine. And that allows collagen to form its beautiful triple helix structure, which gives it its proper elasticity and tensile strength and makes it behave properly, to be able to trap water. All those functions are going to get messed up if you start throwing glyphosate into that mix. So I think that the glyphosate in the lungs is affecting these surfactant proteins that they can't even be secreted into the surfactants. And those proteins are very important as a part of the innate immune system. They actually trap the viruses. So, you sort of have like this tar paper sticking out to trap the viruses, but if you don't have it, then it's much harder for the immune cells to actually gather up those viruses so they can remove them. And so that's a reason why you would have the infection blossom in a situation where those surfactant proteins have been disrupted by glyphosate.
Jeez. Well, it's good information because it allows us to know that it's out there. And this is becoming bigger and bigger because, as we've talked about in the previous episodes, we really forget that our whole body is, it's protein, it's collagen. And if that glyphosate is in there, we're becoming glyphosate bodies. And I never like to be like overly negative on this, but it has to change. Now, we're also mitochondrial, we are energy generators via the mitochondria. How is that being affected in this situation?
Oh, I have an incredible story about the mitochondria that I've been building over the last year. I was aware early on that glyphosate actually damages the mitochondria. That's been shown in studies that it causes oxidative damage. It depletes glutathione. It causes glutathione to be oxidized so that you end up with I don't know if you know, glutathione is a really important antioxidant that operates in the mitochondria to protect them from oxidative damage. And they generate a lot of oxidizing things through their work that need to be cleared quickly in order to prevent damage. And glutathione plays a super important role in doing that. And studies have shown that glyphosate, well, interestingly enough, glyphosate increases the expression of enzymes that make glutathione and enzymes that break down glutathione. There's an enzyme called GGT, gamma glutamyl transpeptidase, which breaks glutathione down into its independent amino acids. So glutathione is very, very interesting to me because that's a sequence of 3 amino acids. And glycine is one of those 3, cysteine, glycine, and glutamate. So if that glycine gets replaced by glyphosate, that's going to mess up glutathione so it can't work. And that's going to cause the body to have to make more. So basically, I think what's happening is that the glutathione is getting assembled with glyphosate, and then the body recognizes that it's broken, so it has to disassemble it and try again. That's why the enzymes that both make and break glutathione are upregulated, are increased in the context of glyphosate exposure. And so the mitochondria get damaged, and then mitochondrial damage is, I think, a primary factor in many, many diseases that are going up in step with glyphosate usage. I think it's a critical piece of the puzzle. The mitochondria are not working properly. And so recently I got involved in the whole idea of deuterium. And I don't know if you know anything about deuterium.
I know of it, but I'm not educated on it, so go for it.
Yeah, well, that's the way I was too. Up until last December, just a year ago, when I first got introduced to the idea that deuterium might be something important in biology, I knew it was heavy hydrogen. You know, it's an isoform of hydrogen. It has an extra neutron. So hydrogen is the smallest atom, you know, on the periodic chart. It's the guy up on the left corner. 1 proton, 1 electron. And deuterium is hydrogen plus 1 neutron. So it's about twice as heavy as hydrogen. And it has different biophysical and biochemical properties. It's present in nature at about 155 parts per million. So, for example, in seawater. And that may sound small, but when you realize how much hydrogen there is, it's a lot of deuterium, because hydrogen, 99% of the molecules in our body are hydrogen. It's quite stunning. And so 155 parts per million on that is still a lot of deuterium. It's present in the blood, I think, at a concentration of something like 6 times as much as calcium. And we think of calcium as an important mineral. So it's not trivial, you know, the amount that's there. And the interesting thing is that it's very, very important in biology. And biology has developed sophisticated mechanisms to manage deuterium. And I learned about this from Laszlo Boris, Professor Laszlo Boris, really fascinating guy from UCLA, very bright. And he comes from Hungary. So Hungary is actually, it's a lot of the work on deuterium the research has been going on in Eastern Europe and in Russia, Ukraine. You know, the West hardly has any idea about deuterium. It's like, if you ask a doctor, he probably hardly knows what it is, you know?
Yeah, it's definitely not something. I mean, I've heard of it, but that was through my own studies. But I never actually dove deep into it, and I've never heard any scientist or physician over here even talk about it.
Yeah, it needs to be center stage, because once I learned about it, and it made sense to me immediately that it would be the glyphosate would affect it, and that's because and it's really fascinating physics that you have to learn, and it's hard stuff actually, but the really cool thing is that there's this mechanism called proton tunneling, and protons are much better at it than deuterons because they're heavy. It's a way for protons to kind of get past an energy barrier. And there are various enzymes that have designed themselves around the concept of exploiting proton tunneling to do their job. And the consequence is that those enzymes know how to refuse deuterium. So when they take a hydrogen atom off of one molecule and they put it onto another, that's their job. They know it's not deuterium. They won't take it if it's deuterium. So the product becomes deuterium depleted. It's really, really cool stuff. And there are all these enzymes that can do that. And they talk about the kinetic isotope effect, which is the degree to which that protein is able to favor hydrogen over deuterium. And various proteins have various levels of skill as far as getting rid of deuterium. But there are all these protons that are very important in metabolic processes. And when you look at them with this new perspective, you realize that the entire machinery in the cell is focused on delivering water to the mitochondria that does not have deuterium in it. It's a whole high-level protocol in the cell that's going on that's really, really remarkable. And it explains why certain proteins are in the cytoplasm and certain of them are in the mitochondria, certain are in the membrane. When you find out why is this protein here, oh yes, of course, because of deuterium. It's really quite beautiful. And I've been going crazy reading about all the different proteins and where they're located and whether they have this, effect, because you can find out that in fact they're passing around these hydrogen atoms from molecule to molecule, finally saying, here, mitochondria, here's this beautiful hydrogen, please take it and make water out of it. And the mitochondria need to have low deuterium because they pump hydrogen, they pump protons into the intermembrane space. The mitochondria have this space inside their membrane, and they pump protons into there and make it acidic. And then they create a voltage drop across that into the matrix. The matrix is the interior part of the mitochondria. And then those protons get pumped in, and then the protons come back out, creating what's called a proton motive force that drives the engine to make ATP. So it's super, super important for the mitochondria. They have a really fancy system that they use to make ATP, taking advantage of protons pushing on that, trying to get across that barrier because there's more protons over there than there are out there. They want to get out. They create a force. The force makes the ATP. And if they're not protons, the deuterons mess up those pumps. This is what Laszlo Boros taught me. The deuterons disrupt the ATPase pumps. They actually break them.
Oh, wow.
And then they start spewing out all these oxidizing agents and cause trouble. They basically get like sugar in the gas tank. They're gummed up. They don't work. Mitochondria get sick. They spew out all these bad things, and they can't make ATP. It's really, really wild.
You break the ATP, kind of break the human, don't you?
Absolutely, absolutely. And you basically have all the mitochondria in your body are getting sick as they're accumulating more and more deuterium. I think this is happening over the lifespan. And the faster you accumulate deuterium in your mitochondria, the faster you age. This is what I think. It's really very, very high level concept in biology that I think is going to revolutionize biology. I'm very, very excited about it.
Have you ever, I know you're very, very intense in this world of finding out the source and the physiology behind it. Have you ever dove into maybe some of the solutions on how we're going to, whether it's reverse or stop this or get the body, I mean, and this is the world I work in, is like obviously trying to find ways to get to detox the body out, things like that. But have you ever dove into that part, or you're really more just like kind of in the source part of it?
Well, I would love to see solutions, and certainly one solution is just to avoid glyphosate. Eating organic, I think, is a huge solution. My husband and I have both found, we've been eating organic now for years, certified organic. It makes a huge difference in your health. You'll find your health problems clear up. And so that's really important. Just try to avoid it. Of course, it's not possible to fully avoid it in this country. Obviously, if you're breathing it, you're living in New York City, you have to breathe.
You're actually the person I promote the most on that, because I will have people say to me, well, organic is so expensive and we're not able to do it, and this, and I understand it's more expensive, and I always go back to, because I remember seeing one of your PowerPoint slides on one of the seminars you did, and I'm like, Dr. Seneff says you have to go basically full organic to have a shot at it, and even though yes, it's more expensive, the costs of the testing and the medical bills, etc., involved with the sickness
pain and agony
from
of being sick
glyphosate is horrendous.
Yes, absolutely. I totally think it's worth it. And of course, I'd like to see the price go down. And I actually, I've talked with some people who are working on exactly that. That's some really fun stuff happening with these kind of, there's Carlo Mondavi is a friend of mine, and he's been working with some people to develop a tractor that is it runs on electricity, and it's a smart tractor. It's a robot, and you can actually train it to go into the vineyards and kill the weeds through natural methods, like using hot water or stomping on them, killing the weeds without using chemicals. and doing so without assistance from humans. So I think it's a brand new thing that he's developing, and I think that's just really, really exciting to think about ways to make organic agriculture not so expensive by reducing the need for humans. And I think if we think about it, we can do it. I mean, the people who know how to do robotics has come a huge way, as you know. It's been replacing humans in so many different ways in the factory. And we aren't devoting enough energy to that because we think we have a solution with all these herbicides, but we don't. We have to get rid of them. We have to get rid of all the herbicides. And so I think the solutions are really to produce the food that's healthy and stop selling the toxic food. That's the biggest solution. But there is also then the concept of, once I've been poisoned, now I'm sick, what do I do? And I do have other friends who are promoting products that have become quite popular. Yeah. So people are finding they're effective. And I think one that I really like is Zach Bush. I don't know if you know Zach Bush.
Yeah, Zach Bush is great. His product's phenomenal.
Exactly. Yeah. So it's I don't know anyone who has said, "Oh yeah, I tried it, didn't work." I mean, everyone is saying, "Wow, it's fantastic. It's straightened up my gut. I feel better." So and I guess it was originally called Restore for Life, and I think now it's been Ion Biome.
Yeah, it's a different name now. I actually Googled it one time. I'm like, "Uh-oh, did something happen? It's different." And I realized it's just a name change. But yeah, I've heard really good things about it.
Right. And there's another one, Biomedic. And I also talked to him. I forget his name now, David. I'm sorry, I forgot his name, but Biomedic, he's an interesting guy too. And he's been developing products that can help to fix the gut. I mean, the gut, of course, gets hit really hard by glyphosate. And that's where your troubles start, because the gut microbiome is so important for your health. And we are now finally realizing that that's true. We didn't notice the gut back when it was working, but now that it's not working anymore. And so sometimes people take probiotics. I definitely think eating probiotic foods, I've become more interested in that recently, especially because I think it's connected to the C virus, because countries that where probiotic foods are popular seem to have less risk of bad outcomes. So Germany has sauerkraut, and Japan has natto, which is stinky, and then there's stinky tofu in Taiwan, and then there's kombucha and kimchi in South Korea, and all of them have relatively low rates of the virus mortality compared to other places. Germany, does well compared to Europe, but doesn't do well compared to other parts of the world.
It's all those wonderful folks in those societies out there and civilizations that it's sometimes crazy that the poorer people who are still living off the land are technically the healthiest, even though they don't have a lot of money. And I've always said, and I love the fact when you come on, you take the science, which sometimes people struggle with. And there's a lot of scientists out there who are just like medicine. You're one of the brilliant ones that really brings the natural world in, showing, hey, this is the problem, but let's do good things to actually fix this, versus like, science, medicine. And like, even the idea, if you had robots, like if technology could work with also killing weeds instead of spraying glyphosate, I mean, that's really the world I think we all want to live in, is live in traditional, sense, along with some technology that can do amazing things.
I agree. Yeah, I think if we can learn to apply the technology to produce organic food more economically, then there's nothing to complain about. That would be fantastic. And I think it would also persuade the farmers to switch, because the farmers don't want to be exposed to these toxic chemicals, And so I'm hoping that enough people will. I'm excited about the organic availability in the grocery stores. I mean, organic food is showing up in regular grocery stores, and in fact, it's flying off the shelves.
True.
My husband just went to get bananas the other day, and there was like 3 bananas left on the organic side, and there were huge numbers of bananas on the other side. So
people are waking up.
Yes, I think people are starting to really notice that they should be eating organic. And then as in the grocery store sees there's demand. So, Whole Foods is starting to produce their own version of various organic foods. So there's, as you get awareness in the marketplace. So I think that the drive that's going to really work is to get people to be on board with the idea they have to eat organic, put pressure on the producers to supply us with organic food. And I think they will rise to the occasion if they know there's a better market, and they know they'll be safer if they're not exposed to the chemicals themselves. Eventually the farmers will come around,
Yeah.
And that's what we need. We really need to just get rid of these chemicals. And of course, not just glyphosate. We have so many other chemicals, and glyphosate makes the other chemicals more toxic than they would otherwise be. So it's a compounding problem because glyphosate disrupts the liver enzymes that detoxify a lot of these organic, organophosphates and things like that. So we're getting hit harder by the other chemicals we're exposed to if we're also exposed to glyphosate.
Absolutely. Now, you have been doing tons of research on obviously glyphosate, but also the vaccine issue, and we now have this thing coming up with the virus and this whole thing pushing vaccines, which have been done in record time. And I'm personally completely against the whole situation, but you're also very much a scientist and you research this. I would love to hear a little bit of your ideas and viewpoints on this as they start pushing this new vaccine or double vaccine or triple, whatever it is, and the implications of this, because obviously glyphosate, GMO food, GMO cultures, you name it. What are your thoughts there?
Yeah, well, first of all, I'm very annoyed with them for not mentioning the obvious ways you could protect yourself from the disease, which is, for example, just get out in the sun and make sure you've got high levels of vitamin D, right?
Right.
Just get yourself some sunlight exposure, eat some fermented foods, get some vitamin K2, eat foods that are rich in B vitamins, make sure you've got plenty of zinc. These things are so simple. And of course, eat organic, stay away from toxic chemicals. If we told the population to do that, if the government would tell us to do that, we would be so much better off. People could protect themselves that way without even, I think, even the masks would become less necessary if we had all of that. So the vaccine, I'm very, very nervous about the idea of a mandated vaccine. This has got me looking for another country to live in, to be frank. It's like, I just would be horrified. I've never had a flu vaccine. In fact, I looked into the flu vaccine because that's a good example. And they're forcing the flu vaccine right now. For example, in Massachusetts, they've suddenly required a flu vaccine for the kids to attend school, which I find horrific. And they're thinking that if you vaccinate from the flu, then they're worried about the combination, all these things. That's the problem is these things seem very logical and make sense. So it's hard to necessarily persuade people that they're wrong. But I looked at the flu vaccine. There's a paper that just came out looking at the flu vaccine uptake rate among the elderly, so over 65, in countries around the world, and just a scatter plot of death rate from C virus on one axis, and then uptake of the flu vaccine on the other axis. So like countries that had under 20% of the elderly people getting the flu vaccine were in the lower left corner. They also had very, very low death rates from C virus. So the same countries that had the very low coverage universally had very low death rate from C virus. In other words, as you have higher levels of coverage on the flu vaccine, death rate goes up. And it gets really scattered towards the right. You have countries all the way from, with high coverage, like over 90%. You have some that have very low death rate from C virus, but also the highest death rates from C virus are showing up with the countries that have the highest coverage of the flu vaccine. So that it's definitely an upward trend. More flu vaccine is bad, but it's very scattered towards the right. But the left corner, very low flu vaccine, very low C virus, is all 100% in that corner. Very, very interesting. So why are they telling us to get this vaccine, which seems to be actually correlated with increased risk to death? Now, I suspect it has to do with countries that use a lot of glyphosate also have high coverage of the flu vaccine, and that's why you're actually seeing a glyphosate effect. Because on that right side, there are countries that don't have high death rates despite having high flu vaccine.
Right.
In other words, a flu vaccine may not really be the problem.
I,
But
and,
there's
and
certainly,
I had a conversation with Dr. Judy Mikovits a while back, and
I like
she's
her.
she's totally convinced, and I don't disagree with her because of her background, that they've snuck in some stuff into the flu vaccine to where that would actually then show and you would test positive for the current viral issue. And so that's a very interesting
Whoa.
viewpoint on that, and I could see where that could happen.
That's really scary. I mean, you really can't trust them with these vaccines. I'm also very, very concerned about the fact that this new vaccine that they're rolling out is a completely new kind of vaccine.
Yeah, let's talk
They're
about that.
doing,
This is the messenger RNA, correct?
yes, very. Yeah, there's two different new kinds of vaccines that they're experimenting with all these different kinds of vaccines with this C virus. And there's both messenger RNA vaccine and DNA vaccine. The DNA vaccine is really strange because they've taken, the virus is an RNA virus. It has RNA. And they take the RNA and they convert it to DNA. And then they inject the DNA. So the DNA is your body, your cells take up that DNA and they use it to make RNA and then to make the viral protein, which is how you get the antibodies. You know, the whole thing. You are calling on the human genome to incorporate that DNA and to make RNA from it, which sounds really, really terrifying to me. And that's a very big disturbance of our genomic processing in our cells. I just would be very suspicious of something like that. And even to just expose, to inject RNA or DNA, either one of those are both very, very allergenic when they're just loose. You know, you don't expect them to be just loose in the tissues like that. So of course it's going to cause an immune reaction because of that. Your body's like, what, you know, what's this? How did this get here? This is really bad. To think that it could have come here naturally means that my cells aren't working at all. There's something really wrong, you know. Cells are dying and spilling stuff out. I mean, you basically are sending a message to the body, to the immune system, to say, holy cow, this is really bad. And that causes this intense reaction that, you know, produces these antibodies, which is what they think are going to rescue you. But the other problem is that this virus evolves very, very quickly. So I think that the vaccine is going to wear off very fast. So are we going to be getting booster shots every 3 months? I mean, I think it's just terrifying to think of that as well. I just think there's going to be autoimmune disease. And of course, we're rushing everything. We're not giving it a chance to get a sense of how many side effects there are, what kind of side effects, what should we expect. We're just going to let it go out into the population and let the entire population of the world be the guinea pigs that are being tested to find out what this thing does. And very, very scary, very reckless, in my opinion.
I think they're trying to play God with the population, personally.
Yes, I know.
And that's obviously, it's conspiratorial or not. It's a very difficult road to go down and kind of look at to see what they're doing. But it's you're altering, when you alter DNA. I mean, how much more from a physiological deterioration standpoint can you get? I mean, is that going that will cause debilitating issues and diseases, correct?
I mean, I can't imagine. I just think that it's very reckless to think that it's just going to be fine and nothing bad's going to happen. I just think that's extremely naive. And that's what frustrates me with all of this research. You know, all the CRISPR stuff, all this what could go wrong kind of attitude about the GMO technology, when actually I think there are probably many things that could go wrong that we can't even conceive of. We're just really, really messing with life when you do things like that. You're creating a very, very unnatural situation. And the immune cells take it at face value. It's like they're like, well, how could this have happened? You know, and they're thinking, well, if this has happened, it must be something horrific going on. They can't imagine that somebody injected it into you. They think it came here naturally through some bizarre mechanism that they don't understand. And they're like, this is terrible. We've got to fight. You know, we've got to fight hard and cause autoimmune disease. I mean, all those things that are going to happen because of the body's response to this bizarre situation that it doesn't understand, you know?
Now, I'm assuming that even with this new one, because, and I don't know the ingredients, I don't think anybody knows at this point until the first insert comes out, but I'm assuming there's GMO and there's glyphosate in this thing. Now, the fact that this goes in and alters its messenger RNA, but also DNA, would that not mean that we're going to be directly now altering RNA and DNA with the glyphosate? Because that is that a whole new world.
It totally is. And I have really suspected, and you probably know that there's glyphosate that's been found in various vaccines. This is something I found really shocking. And I actually think the MMR vaccine in particular, part of what's making it so bad is glyphosate contamination. And in fact, it produces a protein which it's called hemagglutinin, and it actually has a sequence within it that resembles a sequence in myelin basic protein. Myelin basic protein is in the myelin sheath in the brain. And so they have found that there's several papers by a group of researchers in Utah. Professor Singh, S-I-N-G-H, is the lead author on these papers going back to the 1990s, where they were proposing that this hemagglutinin, immune reaction to hemagglutinin producing antibodies that then attack the myelin sheath through this molecular mimicry process that has to do with the fact that it resembles the protein, makes a mistake because it looks like it's the virus, but actually it's the myelin basic protein. and that could be a way that MMR could be causing autism by attacking. If in a child that has a leaky brain barrier, that has a weak immune system, and then the virus gets into the brain, the immune system in the brain produces antibodies that attack the myelin sheath. I think that's a really interesting and scary scenario, and I think it may be foundational in the way that MMR might be affecting the autism. But the thing is, that particular sequence actually has 3 glycine residues in both of the patterns. So the two that are similar match on 3 different glycine residues. So that gives opportunity for glyphosate to go into the hemagglutinin in the virus when the virus is being grown on glyphosate contaminated nutrients, which is what's happening. So you can imagine a rogue version of that hemagglutinin with glyphosate in it, which is going to be extremely allergenic and then causing all this stuff to happen. So it's quite terrifying. And MMR had by far the highest levels of glyphosate in it compared to any of the vaccines that they tested. Both Anthony Samsel and Zen Honeycutt tested several different vaccines, and they consistently found a pattern that the vaccines that were live virus vaccines, not the ones that have just sort of antigen, like, the ones that had aluminum in them typically were not live virus because the aluminum would actually kill the virus. So it's the MMR and the varicella and flu vaccine. Flu vaccine is one that was contaminated. And so, the idea of injecting glyphosate in the context of everything else that's in the vaccine is just terrifying to me.
What makes me feel really good though about this whole thing is people like scientists like you out there. We live in this pharmaceutical paid science world right now, which is obviously dominating the public, it's dominating government, etc. And it makes people think that is the only thing out there. But then there's people wonderful like you, as well as this Dr. Singh and others. It sounds like, because I don't follow this, but there are people like you out there who are doing this science every day and showing that there might be an issue here. What are the health ramifications of this and that, etc. We just need to bring basically you wonderful scientists to the forefront because the research is being done. It's just that the paid stuff, the paid science is winning right now. We need to kind of flip that. You must know a lot of people who are doing work like this.
Not, you mean like my work?
Like your work and Dr. Singh, who are actually showing what's going on.
There's a handful. There's a handful of really dedicated people who are really making a difference, and they're all basically in a situation where, of course, pharma's not funding their work because pharma doesn't want this work to be done. That's the thing. The money is in the research that's the wrong research. So we're spending our money very foolishly right now. It frustrates me that. For example, even that the American researchers are practically clueless with respect to deuterium, and I know deuterium is extremely important, and they dismiss it. They don't even know about it even. So we're not communicating with the East to find out what's going on over there. Otherwise, we would know about deuterium. And that's just one example. But the whole agenda of the research is geared towards so it's kind of like let's find some metric in the body that's correlated with some disease, such as high serum LDL, high cholesterol correlated with heart disease. Let's find some poison that can knock out the enzyme that makes this, such as a statin drug, right? And then let's make a story that makes it look like the statin drug is actually doing something good. And then we'll just make a killing selling this stuff, poisoning everybody. That's how the pharma seems to work. It's a completely broken model.
Wow. What is your work going into the next several months and in the near future? What are you focusing on?
Well, I'm focusing right now on a book. So I'm working very hard on a book on glyphosate, which I'm hoping will come out maybe June of next year. The title will be The Glyphosate Effect, and then there's some kind of a subtitle we haven't quite worked out yet, but The Glyphosate Effect, all about glyphosate. And hopefully that will help to at least get people to know my thinking about what's going on with glyphosate. And then, as I mentioned, deuterium. So I'm very much interested in deuterium, mitochondria, and glyphosate. So that's been my big research topic lately, and I'm finding that it's fitting into all kinds of diseases. So I'm hoping to write a second book. I'm actually sort of playing around with notes for a second book that will talk about COVID, the C virus, deuterium, glyphosate, and mitochondria.
Wonderful. And where can people best find you? I know you have a website. What is that?
I have a better website now that's just stephanieseneff.net. At least it's easier to remember. It's
So,
StephanieSeneff.net, and it points to the other one. There's an MIT website there where I have a lot of material. You can find all my papers and stuff and
oh,
various
I like this
interviews.
one. This is the, oh, I like this, Dr. Seneff. This
It's a bit
is
of an
this new since
improvement.
I talked to you last?
Yeah, this is a new. That's right. I only had that for a couple months.
I
And
like
get ready for
this.
my book. So
That what okay, now you have to now you have to describe this picture of you on the homepage. What is
I,
this and when was this?
a few years ago. That was way back when I was young. Yeah, with my black hair, right? And I was working at Lincoln Laboratories, and that was a fancy computer that we had, which was, one of these big things that has very little memory. But working on a computer at MIT many
Wow,
years
that's
ago.
great. I love that. That's a great picture. Were you just in school at that point? Was that like the beginning of the
It's actually in the period between my undergraduate and my graduate degree. I actually worked for 10 years at MIT Lincoln Laboratory in computers, writing computer code before I had had any training. Because in those days, you could get a job in computers without any training. So I was learning on the job. But I wrote computer code to process speech, actually, speech processing with computers. And that's been most of my career, precursors to Amazon's Echo and Siri, Apple Siri.
Wow. This is this is fantastic. Has some of your interviews in here. This is a great website. I love it. And
Good, thanks.
it has your research and your work here, correct?
Yes, well, it has links that if you want to learn more, click here. That should take you to my MIT webpage, which just has a huge list of all kinds of stuff. There's all kinds of PowerPoint slides and interviews
Oh, there you
and
go.
papers. Yeah, very, very primitive looking, very straightforward webpage with a lot of material on it.
Well,
So
that is absolutely wonderful, Dr. Seneff. It's always a blast to have you on, and I love how you actually are able to take the physiology and the science, even though not everyone understands the pathways and the channels. The more you're on, and you're out there in YouTube land all over the place, the more you're on, the more people are learning it and they're understanding it. And then they go research for themselves, they dig for themselves, and it's really coming higher into consciousness, and people are starting to wake up, which I think is absolutely wonderful. So I thank you for continuing to do all the amazing work you do.
thank you. I'm so glad I'm very appreciative of people like you too, because I know it takes a lot of work to do all these interviews and get them up there and all of that. So thank you too.
You're very welcome, and I will definitely you'll be back. You'll be back when we get these books out and everything else, so we can teach the world. But thank you again for being on, and you are amazing. You're a warrior. Just keep doing an awesome job. You are literally saving lives every day.
Thank you so much.
You're very welcome. Dr. Jason Dean, this is Dr. Stephanie Seneff, Revolution Network. Please go to her site, stephanieseneff.net. She's an amazing woman, and she is fighting the good fight. You guys have an amazing afternoon, amazing day, and let's go win this whole thing, and let's take care of humanity. Take care of yourselves. Share this video everywhere. We need to wake up humanity. Have a great day.
Thank you.